US Physics Olympiad year 2014 USAPHO Final round. Problem B1. A block of mass big M has a hole drilled through it so that a ball of mass small m can either horizontally and then pass through the block and exit vertically upward. The ball and block are located on a frictionless surface. The block is originally at rest. Question A. Consider the scenario where the ball is traveling horizontally with a speed v0. The ball enters the block and is ejected out the top of the block. Assume there are no frictional losses as the ball passes through the block, and the ball rises to a height much higher than the dimensions of the block. The ball then returns to the level of the block, where it enters the top hole and then is ejected from the side hole. Determine the time t for the ball to return to the position where the original collision occurs, in terms of the mass ratio beta equal big M over small m, speed v0, and acceleration of free fall g. Question B. Now consider friction. The ball has a moment of inertia I equal 2 over 5 mr square and is originally not rotating. When it enters the hole in the block, it rubs against the surface so that when it is ejected upwards, the ball is rolling without slipping. To what height does the ball rise above the block? Solution. Question A. First, we have to emphasize that here we have horizontal momentum conservation and energy conservation. It means that we can find what is the speed of block and ball in the moment when the ball is start to fly. That will be momentum conservation. M small plus M big multiplied by Vx, where Vx is a common horizontal speed. That's equal initial momentum, which is M small multiplied by V0. And from here we can find what is Vx. This is this expression. And now we can find, using energy conservation, what is the initial vertical velocity of the ball. From this energy conservation we can find what is Vy square. That will be this expression, V0 square multiplied by big M over small m plus big M. And now we can find what is time to fly for block. That will be T1 equal 2Vy over G, or using Vy from here, we can put it here and find the expression for T1. And the last thing, we have to find what is the time to travel for this ball back to the initial point. Because we have absolutely elastic interaction, we can use here formula for velocities after absolutely elastic collision. That will be this expression, small m minus big M over small m plus big M multiplied by V0. From this formula we can find that if small m greater than big M, this velocity will be positive and ball will never reach initial point. So it means that small m must be less than big M to count this time. So first we can count what is the distance covered by block during time t1. So this distance s will be Vx multiplied by t1, which is this expression, and after all this expression. Now we have to find what is time to cover this distance for the ball to make it an initial point. That will be t2 equal s over v small x, which is this one. And we have to take a positive value. That will be this expression, and the total time will be t equal t1 plus t2, which is this one plus this one. And finally, when we use beta, which is equal big M over small m greater than 1, we have this formula for total time. That's the answer for question A. Question B. Now we have a motion with friction. And main thing here is that when ball enters this block, it's not rotating. It means that we have kinematic friction between ball and the block, and this ball starts to decrease due to friction too, and also it starts to rotate due to friction. And finally, when this ball leaves the block, it rolls without friction, and this is important point. We can use it. So during the motion inside of this block, we have a change of linear momentum and a change of angular momentum for block. And there are equations. Change of linear momentum, delta p, that's equal force multiplied by delta t, and the change of angular momentum equal force multiplied by radius multiplied by delta t. Or we can rewrite it in form of, we have these two formulas, and here we have force of friction, which is not constant, but still we can do integral for both of them. Basically, as a result, we have the same integral for both equations, and we can just equalize both left parts. So we have delta v equal 2 over 5 r omega. Now let's check what do they mean, these variables. Because finally this ball rolling without slipping, we can write that r omega equal a new vertical velocity, which is we call vy prime. And delta v, that's a change of velocity due to friction, which is vy without friction minus vy with the friction. Now we can put these expressions to our equation and find what is a vy prime. So we have this equation to find what is a vy prime, and vy prime equal 5 over 7 vy, which is this expression. And finally we can find what is total height. Total height will be v1 prime square over 2g, or using this answer, that will be answer for question B.